Okay, so let's talk about array data structures. We all know how important this topic is for the UGC NET exam, right? So let's just dive right in and master it.
The thing about arrays is they sound super simple, don't they? But don't be fooled, this is exactly where the UGC NET exam loves to throw the most tricky questions. Today, we're going to crack this code together.
All right, so we're starting right from scratch, absolute zero. We're going to build such a strong foundation that no question, and I mean no question, can shake you.
So, what even is an array? In simple words, it's a collection of items, or elements, of the same type. And they're all stored one after the other in memory, in contiguous locations. Just remember these two things: same data type and contiguous memory. That's the key.
If the definition feels a little technical, just think of a train. Seriously, the entire train is your array. Every compartment is an element, and your seat number, well, that's just the index of the array. Simple, right?
See, when you know your seat number, you can go straight to your compartment. You don't have to search from the engine all the way to the back. It's the exact same with an array. If you know the index, you can access any element directly. We call this O of 1, or constant time access, and it is incredibly fast.
Okay, so now that we get what an array is, let's look at the rules of the game. What are its properties and what kind of operations can we perform on it?
So here are the 4 core rules of an array. First, its size is always fixed. Second, all elements must be of the same data type. Third, they are all stored together in memory, or contiguously. And the most important one to remember for the exam: indexing always starts from 0, not 1.
Now, the most interesting thing on this slide is the time complexity. Accessing an element, that's O1, which is super fast. But the moment you try to insert or delete something, the complexity jumps to ON. Why does that happen? Well, let's take a look.
Imagine you want to insert the number 30 at index 2. You can't just drop it in there. First, you have to make space. You have to shift the 40 one step to the right. Now, if the array was huge, imagine shifting thousands of elements. That could take a lot of time. And that's exactly why the time complexity is O of n.
When it comes to searching, you have 2 options. Linear search is like a tortoise, slow and steady, checking one element at a time. But binary search, it's like a rabbit. It's super fast because it cuts the problem in half with every single step. But, and this is a classic exam question, it only works if the array is already sorted.
All right, now we come to the most important part. The part where UGC NET asks direct formula-based questions. Let's talk about memory representation. Have you ever wondered how the computer finds the memory address of an element so quickly, in O of 1 time? Well, there's a simple little formula behind it.
And here it is, the magic formula. The address of any element is simply the base address plus the element's index multiplied by the size of each element. This formula is the key to solving so many direct questions in the exam, so make sure you remember it.
Of course, arrays aren't perfect. They have a few drawbacks. Because their size is fixed, you can end up wasting memory. And like we just saw, adding new elements or removing old ones, both of those are pretty expensive operations. So after all this theory, let's see where arrays are actually used in the real world. I think knowing this will make the concept even clearer for you. That image you have on your phone, it's basically a 2D array of pixels, a list of student marks, records in a database, even the board for games like chess. They all use arrays internally. And now for the most important section. How do we use all this information to solve questions in the UGC NET exam? Let's do a quick rapid-fire round.
First question, a very common one. What is the access time of an array? Think about it.
Absolutely right. It's constant time, or O of 1, because we can access any element directly using its index.
Next question, what is the single most important condition for applying binary search?
Exactly. The array has to be sorted. Without that, binary search just won't work.
So here is your final cheat sheet. Take a good look at this slide. Array means fast access but slow modification. Binary search needs a sorted array. Contiguous memory is the core concept, and that address formula is the most important thing to remember.
So I think arrays are pretty clear now. But remember, this is just one tool in a programmer's toolkit. The real challenge is knowing when to use an array and when to use something else. Think about it. What data structure solves the biggest weakness of an array? Its fixed size. Let us